In this video, we are going to look at the speed time graph for two objects. It is a past IGCSE question. Figure 1.1 shows the speed time graphs for two falling balls. Both balls fall from the same height above the ground. Part A. Use the graph to find the average acceleration of the falling rubber ball during the first 3.0 seconds. Right? The word is average acceleration. Right? We look at the speed time graph of the rubber ball. It is a straight line. So in fact, the acceleration is constant. So we use a formula: acceleration equals to final speed v minus initial speed u over the time duration, which works out to be 28.5 meter per second divided by 3 seconds, and that works out to be 9.3 meters per second square to two significant figure. Now, bear in mind, we are only justifiable to put to two sig fig because the data given are mainly to two significant figure. Part 2 of the question is much of a recall. It says the distance fallen by the rubber ball during the first 3.0 seconds. We know the formula: distance equal to area under the speed time graph. For the rubber ball, this graph for the first 3 seconds is a triangle. So half base, which is 3 seconds, times height 28.5 meter per second, works out actually to 42.75 meters on the calculator, but as usual, we do two sig fig answer for this same question. Part 3. Ask for the terminal velocity of the plastic ball. Now note that the speed time graph of the plastic ball is totally different from the speed time graph of the rubber ball. It is a curve. Yeah? At the end of the journey, roughly from 3 to 4 seconds, we have constant speed of the plastic ball. Therefore, the terminal velocity is this constant speed, which is 15 meters per second if we read from the graph. We'll go into the mechanics or dynamics of this slightly later in the video. Part B, the qualitative aspects come in. Both balls have the same mass. Now that is important. But the volume of the plastic ball is much greater than that of the rubber ball. Well, this is because the plastic ball has a lower density. Explain in terms of the forces acting on each ball. Now to score marks, you must refer to the forces acting on the ball. Why the plastic ball reaches the terminal velocity but the rubber ball does not? I normally advise my students to use bullet points. 3 marks means 3 bullet points. Plastic ball larger, therefore air resistance on it is larger than air resistance on rubber ball. Point number 2, air resistance on rubber ball is not sufficient to balance weight of the rubber ball. However, point number 3, air resistance on the plastic ball is sufficient to balance weight of the plastic ball. Part C is a straightforward calculation, but take care of units. It says the mass of the rubber ball is 50 grams. Now you have to change this into kilogram by multiplying by 10 to the power of -3. Right? So we let the calculator do the calculation. Calculate the gravitational force acting on the rubber ball. So weight equals to mass in kg times gravitational acceleration, which we will take as 10 meters per second square in IGCSE as well as O-level, SPM, etc. This works out to be 0.5 Newton. So that question is a total of 10 marks. Note that the qualitative part of 3 marks regarding forces is substantial. Now, I would like to talk generally about terminal velocity attained by a falling object. As we saw just now, to do that, the air drag or air resistance on the object, on the falling object, must be sufficient to balance the weight of the object. Let us look at this graph, which resembles the plastic balls curve just now. The plastic balls curve, speed time curve just now. So at the outset, from 0 or from O to A, that means at the initial stage, the weight of the ball, say W equal to mg. Using Newton's second law, F equals to ma, since there is no resistance, no air resistance, so mg equals to ma, which works out to be A equal to g. Meaning, if we draw a tangent at the initial point, the gradient of this speed time graph actually gives us g, which should be close to 10 meters per second square on Earth. As the ball picks up speed, because it accelerates, one thing happens, however. Air resistance increases with increase in speed. So, mg is a constant, r is an increasing quantity for the blue part of this curve. Therefore, resultant force decreases with increase in speed, because with increase in speed, mg is constant, r increases, the resultant force decreases. When resultant force decreases, of course, acceleration decreases. Look at the gradient. Look at the gradient. At the lower speed, it's steeper. At the higher speed, it is more gentle. Meaning, from 10, the acceleration is dropping between section A and B. There will come a time, for this case, where the speed continues to increase until the point when the air resistance is equal in magnitude to the weight of the ball. Then mg minus r equals to m times 0, meaning the resultant force is 0. That is air resistance, which is represented by r, is balancing the weight of the ball. So resultant force becomes 0, acceleration becomes 0, terminal velocity is reached. So this terminal velocity is this sort of maximum velocity attained by a falling object. Thank you.